Hi, this is Adam from Makerspace, and I'm here with our 5th webinar for the Maker Partnership Program. Right now, we're going to discuss Scratch Basics number 2, Floppy Fish. So before we dive into the Scratch, I just want to reference our Makerspace weekly prep checklist here and make sure we're hitting all of these things and keeping all these things in our mind as we start to get into more of a rhythm of delivering these Makerspaces. So obviously, you want to prep your lesson using the STEM Collab, taking the quiz there and watching the videos to get yourself prepared, as well as reading the lesson plan. All those things you can find right in the STEM Collab. And most importantly, building or coding your prototype yourself before you go to deliver your Makerspace. That's most important because we want you to be showing your prototypes to your students, and we want you to be prepared to answer any questions or anticipate any challenges that they might have as they program their own. Okay? So prepping your Makerspace technology, your laptops, your internet, making sure your students all have accounts that they can access, things like that. And then printing or prepping any supports. So that includes the rubrics and the challenge report, which you can print via the STEM Collab page again. And also your design cycle poster and your magnets and your badges, having all those ready. And we really want you to be using that design cycle poster to guide your students through the 3 stages of the design cycle, as well as highlighting your STEM idea and those vocab words, and we'll talk about that more in a second as we enter the discover phase. Taking attendance and facilitating your Makerspace, that should be fairly regular at this point, and then using your rubrics to monitor mastery as your students make their way through the challenge. So distribute those rubrics at the beginning of the class, and then they can assess themselves and understand what's expected of them as they progress through the challenge. Okay, at the end of the Makerspace, you can hand out your Makerspace challenge reports, which will go to parents or administrators or other people. And then finally, sharing your successes and your experience in the STEM Collab with those prep and practice prompts. And then you can start prepping for next week. So just to quickly refresh on all those things, hopefully those things are becoming part of your regular rhythm with delivering these challenges anyway, but I just wanted to refresh quickly. Okay, so moving on to Scratch Basics number 2, Floppy Fish. And for these, you need the same materials that you need for all your Scratch challenges. Charged computers, internet access. Optionally, you can use your pre-printed Scratch blocks for some do now activities or some pseudo coding, and then your rubric and parent report. And with that, let's take a quick trip over to the STEM Collab for this challenge. So here is Scratch Basics number 2, Floppy Fish. We have our intro, and then we have our links to our challenge materials. Lesson plan, Scratch project prototype, which would bring us right here to this Floppy Fish page. Whoops. Our rubric and our challenge report. So these bottom 2 things you're going to want to open and print and bring 1 copy per student to your Makerspace. Okay? And below that, we have my video for the create section of this challenge. So this is a video just dedicated to building the challenge. We're not really going to touch on that during this video. And then a short quiz to test your understanding, and then your prep and practice prompts to share your experience before and or after completing this session. And a note, make sure you share your Scratch projects inside of Scratch if you're going to be posting links to them, because otherwise they will not be accessible after you share the links to them. Okay, so with that, let's go back over to our slideshow and go to our discover phase. So hopefully you're using your design cycle poster to write out your STEM idea and keywords and display those so that students can think about them and have those visible while they're starting this challenge. And this challenge is all about using if-then statements and XY coordinates to control the position of the sprite, okay? Of any sprite, I should say. So an opening question focusing on XY coordinates might be, how do we describe the position of something on a map? And hopefully you'll have a student that can come up with longitude and latitude and make the connection between using longitude and latitude on a map to using XY coordinates on a grid, okay? Another easy way, let's go back over here. Another easy way to show this connection, if you're in Scratch, is to, let's just see inside this quickly, to load up a new backdrop and use the XY grid backdrop right here. And looking at this backdrop here, we can see the X and Y coordinates and how they relate to positions on the stage. So we have 0, 0 right in the middle. X gets larger as we move to the right. It gets smaller as we move to the left. Y gets larger as we move up, and Y gets smaller as we move down. So we have our X and Y coordinates, and notice that X is always written first, regardless of which coordinate is bigger or what position we're in. X always comes first. So left and right, then up and down is the order of those coordinates. Okay? Let's shrink that, and we can get rid of that and hop back over to our slideshow. Okay, so start with an opening question and then show your prototype and the new scratch blocks. So the new scratch blocks in this challenge are if then. Well, we used if then a little bit during the Great Race, but we're going to really use it a lot during this challenge. So we have if then, forever, change X, and change Y. So you might just want to quickly pull these blocks out here. And without diving too much into this script right now, just highlight the change X, the change Y blocks, and how those work to move the position of our sprite. You can see as I'm clicking them now. And importantly, that we can change the numbers in these blocks, so making this a negative number instead of a positive number, so on and so forth. Okay? For if-then statements, we're going to use both the if-then and the if-then-else statement, so just showing the difference between those. An if-then statement we're using for our left and right movement, you can see here, and also for our touching color blocks down here and touching cheesy puffs. Our if-then-else statement is giving us this choice between upward or downward movement depending on whether or not we're pressing the space bar. Okay? And then finally wrapping all of this in a forever loop so that it runs over and over. So these are our new blocks for this challenge. So just make sure to introduce your students to those before they dive into programming this themselves. And all those blocks relate pretty closely to our vocabulary keywords, our X, Y coordinates, the change X and change Y blocks we're using for those X and Y coordinates, as well as the the go to XY block, which we're using here and up top here. Whoops. And then our if-then statements and our loop, which is our forever loop, okay? So another thing that you can do as you're introducing this challenge is ask your students to use their printed scratch blocks to define different possible pieces of code in this project, okay? And a really easy way to do this for this project specifically, if we look at our code for this project, this is really just a list of if-then statements inside of the forever loop. There's 5 of them, okay? And what you can do is just ask your students to only name if-then statements that appear in this code. So don't show them the code, but maybe have someone play test through your project, and then after they play test, have the class try to list as many different possible if-then statements as possible that are active in this. And once you get to 5 or 6 of them, you'll basically just be translating those statements into code as you program them. So it's an easy way to see the connection from pseudocoding to actually coding. And lastly, demonstrate X and Y coordinates. So we talked about that, how they're describing positions in the scratch stage using that backdrop to help if needed. Okay? So after that, you're going to go through your create phase, and your students are going to create this project themselves. There's the full other video on the STEM collab that walks you through that. The only thing I'd say is something that's not so code related that can be complicated is the creating of these backdrops, which I do talk about in the other video, but just to highlight, one more time, I'd start with a very simple backdrop, and then you can duplicate your backdrops using that duplicate tool, and then kind of make them, add little pieces to them to make them more difficult over time. Okay? So that's how I'd recommend tackling your backdrops, and make sure you don't make them so hard that the player isn't going to be able to finish the game is my other tip. So start simple. You can always make them more complex, but sometimes it's hard to go from more complex to simple. Okay? So after your students create their prototypes, you're going to move into your improve phase, and they'll do a play test, and you can do your play test either as a group play test, a gallery walk as we call it, where students will walk around giving feedback on each other's projects on Post-its or on a piece of paper, or you can do it as a think, pair, share, and have students trade projects and test just in pairs. Okay? Both are totally fine. But just make sure you have students write down their feedback somewhere so that the engineers can keep that feedback and look back to it in the future if they want to make adjustments or just remember, different challenges that they've worked through. Okay. And here's some play testing questions that can help guide that process. And these are all available in the lesson plan as well. But just simple things like, can the player's sprite move by using the space bar and arrow keys? Does the player get sent back to the beginning when touching the wall? So just asking, these basic characteristics of the game, do they work? And then things like, are there any unexpected behaviors or bugs? And did the engineer do anything to go beyond the challenge or customize their project? That should be taken note of, for positive reason. Okay. And some extra challenges that your students can go try to work on as they iterate after they play test. One thing is to end the game. So by default, the way we have this project set up is that it will just continue to rotate through the different levels after you win, which I'm not doing a good job of doing right now. But when you win, you'll just continue to cycle through these backdrops. If we start on this simple one, we get through one, get through two. Okay, I'm not gonna make you watch me fail at this right now. But once you get through the backdrops, you just keep repeating through. So one fun thing to do would be to end the game, and one way to do that is to just add another backdrop. So I'm gonna stop that. I'm gonna add another backdrop using the paint tool and just say, I'm gonna make the whole backdrop blue and just write in a different color, maybe yellow, you win, and make that much bigger. And maybe I'll change the color on that. It's kind of hard to see. Okay, you win. So now, after you get to this level, again, what our script is doing is pushing us to the next backdrop every time we hit the cheesy puff. So on the fourth level, we'll hit these cheesy puffs and then go to our you win level where we need to write one last script, and that is when backdrop switches to backdrop 5, stop all. So this will stop the game once you reach this final you win backdrop. And let's see if I can just try this one more time to demonstrate how this is gonna work by playing this game. So if we start here, oh, there's a glitch. Let me fix that quickly. So I want this to start actually on backdrop 2 because that's my first backdrop confusingly. But now I'm starting on backdrop 2. I have my directions. I'm gonna try to beat this quickly. One level. Whoops. 2 levels. Okay, this isn't worth it right now. But rest assured, when I reach this last level and beat it, this will end the game on this you win level right here, okay? So there's one of our 2 challenges. And secondly, we can add more obstacles or different sort of collectibles along the way that the sprite can interact with. So one fun way to do this is we can just change what this collectible is going to be from backdrop to backdrop. So an easy way to do that is to use when backdrop switches 2 blocks to change between different costumes and to add some different costumes to this bowl of cheesy puffs. So let's say on the first level would be cheesy puffs, and then I'm going to add another costume from the library, and maybe on the second level, if we choose things, we'll have an apple, and on the third level, we'll choose, it's going a little slowly right now, but we'll choose these that cake, that works. Okay, and that's good enough to demonstrate for now. So we can change our costumes based on the different backdrops. So let me just put 3 of these over here and get rid of this 4th one and make this backdrop 2, backdrop 2, backdrop 3, backdrop 1, and we can change these all to different things. So cheesy puffs, apple. And one thing I'm going to do is go to my script for my fish and make my fish move a little bit slower, so maybe I can actually beat some of these levels here. And let's try this one more time with the end to our game and our now changing item that we're trying to get. Ooh, I really not so good at this game. Okay, there we go. One level. Now I have the apple, and I'm on my second level. Got my apple. Now on the third level, we have the cake. There we go. There's the cake. And here we are on the fourth level. Ooh, almost. Oh, so close. Okay, hold on. One more time. There it is. Okay, and now here's my I win screen. I finally did it. And there are two really simple, quick things you can do to, improve this project a little bit. And I'm going to leave this video here. So I hope you enjoyed this. Oh, one more thing I wanted to point out. So there is a debug challenge available for this challenge in the debugging exercises, Scratch debugging exercises course. And this is the Floppy Fish debug. So what you'll see here is an original version of that challenge, right? And below it is a bugged version of the challenge that does not have the proper scripts in it. So look in here, and there's something wrong with this challenge. When we try to run it, it's not going to quite work the way we want it to, and it's up to you to figure out how to debug it. So right now, this is all broken. I can't move. My fish is just repeating, this little movement over here facing left, and it's not working. So go to this debug challenge and try to fix it if you're looking for a little more extra challenge or to test your skills a little bit, and I hope you enjoy that. So thanks for watching, and hope to see you back for the next webinar. Bye.